Woman world. Today we are going to discuss about a case study. This is a different case study, but on a drive shaft. Means here we are going to discuss a case study on petty failure of a drive shaft. See, this drive shaft is a machine or it's a component that is used in a high-speed machine. Means it is used mainly in the automobiles, that too in a transmission gearbox. Okay, we all know our cars drives at an RPM of from 1000 RPM to something around 5000 RPM. So it is rotating at a high speed. So as I already we discussed in the class, the fatigue is the only failure that happens at the high speed machines. Okay, it's the major failure that happens at the high speed machines. Okay, so we are going to discuss about it. Let's start.
Now we are going to see about the failure in the drive shaft. This drive shaft is the boat's drive shaft in the propulsion. We all know that due to the propulsion, the blades will rotate and the boat moves. So that where the high-speed motors are used, in the drive shaft, the failure is happening. And then now the boat which is sailing in the Western Caribbean coast, like while sailing in the Western Caribbean coast, the boat occurs the failure. And then the steel which was made was low alloy grade 4340 steel. And then the presence of fluctuating stress and the pressure rises made the maximum cause to the failure. Investigation. While coming to the investigation, the failure is occurred in the fillet radius of the shaft drives, and this is comparatively smaller than the provisioned design, previous provisioned design. And the drive is made of quenching at temperature, so that this will not give a sufficient hardness to withstand this.
See, this is a detailed description where this is a diagram where this part is the failure part. Okay, this yellow red color mark is the failure part. So this is the complete drive shaft diagram, and this black area where the red color mark is given is the fracture plane, and this is the broken shaft. Okay, as our friend said, this has happened in the drive shaft of a boat. As we all know, the drive shaft of the boat rotates at the RPM something around 2000. So this is the one of the high speed machine where the fatigue failure occurs. Okay, so here you can see this is the broken one. Here you can see these are the marks. So you will see the detailed view in the upcoming slides. Okay.
Metallurgical characterization. So if we see this in our society, most of the things are made up of certain materials which will be delivered out as a proper component or devices. So for the material, it should have a proper properties like chemical composition, mechanical properties, and certain composition. So if a perfect composition of certain chemicals can give a proper material. For example, if we take the amount of milk and amount of water, then amount of tea powder will be given as a proper material. Likewise, in our mechanical code, for a particular material should have a proper amount of certain chemical composition, so that it could be a best material.
Add to this, see, if you as what he said is a correct point. Add to this, you can see if a material is getting failed, we must first check the chemical composition, as he said. If the chemical composition is not proper, or if it is not right, it should be rejected at the first investigation result. If it is not checked properly, okay, sometimes the failure can occur due to the chemical composition. Then if the chemical composition is altered, eventually you can see there is a change in the mechanical property and the metallurgical property. Okay, so
Chemical analysis. So like chemical analysis carried out optical emissions, which is done by stethoscopy and roughly polished specimen cut at the part surface. So they have done part surface, cut at the part surface. The stethoscopy, it is undergone some emission, optical emission. So these were the proper composition of chemicals for that particular thing. Tensile testing also mentioned here.
And after testing the chemical properties of the metal, we are going to check the tensile character of the metal. What is meant by tensile is the elongation. It's about checking the elongation limit, elastic limit of the metal. Like we have already tested, the yield strength of the casing is 101, and the tensile stress is 140. the elongation is 19% it has been recorded. The elongation of the metal looks good. And let's see about the mechanical properties. We have checked the hardness for in the Rockwell scale. The result average is 30 lecture. The endurance limit is directly reached through hardness value. It's about tempering by the tempering punching the hardness of the material has gained greater property.
So added to this point, you can see as we see about mechanical properties, tensile test or hardness test are the mechanical testing. For testing any mechanical property, the nature or the basic level of testing is hardness testing and the tensile testing. As our friend said,